Okay, so today we're starting a new chapter, although we did the Are You Ready page yesterday, which should have been okay for you. You had to find areas of rectangles. You just have to remember that the area formula, which they gave you at the top of page 532, is length times width. So for example, if you had one side 8 centimeters and one side 4 centimeters, your area would be 8 times 4, which is 32 centimeters. Um, so now we're going to focus on area of parallelograms. So we're on page 537. I'm going to try and do it this way so that you can kind of see your book and do it along with me in the book. If you preferred it for me to do it on the whiteboard, please just send me a note or a private message or something on the stream, and we'll see which way kind of works better for everyone. And it says, so again, we're in volume 2 right now. If you're looking, we're on page 537 in volume 2. A polygon is a closed figure formed by 3 or more straight lines. A parallelogram is a quadrilateral, which means 4 sides, with opposite sides parallel and opposite sides the same length. A rhombus is a parallelogram with 4 equal sides. So it says fill in the lines in the diagram with polygon, parallelogram, or rhombus and draw an example of each. So I'm just going to show you what it should look like in your book, okay? Don't worry about this page. This is from another page that we didn't do. Polygon should be up here at the top, and a polygon, like we said, is a closed figure formed by 3 or more straight lines. So we have a straight line here, 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 here. It could have 4 sides, 3 sides, 4 sides, 5 sides, 6 sides, and so on. There's a lot of different polygons. Parallelogram is going to go inside the polygon circle because a parallelogram is technically a polygon as well. This one is a quadrilateral, which means it has 4 sides, but the opposite sides are parallel and the same length. So this one is the same as this one, and this side is the same as this side. So that's what a parallelogram is. The lines are parallel on either side. And then the rhombus goes in the circle that is inside the parallelogram and the polygon, because a rhombus is also a parallelogram, which is also a polygon. So a rhombus is all 3, which is cool. It's got 4 equal sides, okay? Instead of having 2 and 2 equal sides, all 4 equal sides create what's called a rhombus. If you look at the bottom of page 537, it says expert skateboarders can slide down the railings of stairs safely. A parallelogram is used to build a staircase. So you could see from these 2 blue lines here and the 2 pink lines here. How many sets of parallel lines are shown in the parallelogram to the right? Well, if it's a parallelogram, like we've talked about before, we have 2 sets of parallel lines. The blue lines are parallel, okay, which means that they will never cross each other. This line will continue to go up like this. This line will continue to go up like this. They're never going to intersect like that, okay? Parallel means they're never going to intersect. Same thing with these pink lines. So that's why here would be your answer, 2 sets. Okay, so now if you could turn to page 538. Okay. There are formulas for area, which sometimes you're going to have to remember. Sometimes we'll give you the formulas for them, but it's probably just better off to start memorizing the formulas now because not everybody's always going to give you area formulas. The area of a parallelogram is the product of its base and its height. So very simple. Area of a parallelogram is the same formula as the area of a square and the area of a rectangle because it has 4 sides. Okay, 2 sides are parallel, 2 sides are parallel. So it's really just A equals B times H. Okay, area equals base times height. The area of a parallelogram is related to the area of a rectangle as you discovered, well, it says as you discovered in the previous inquiry lab, which we actually didn't do. But the base of a parallelogram can be any one of its sides. Base does not have to be the bottom. The base could also be the top. So just remember that because sometimes they'll give you information and you'll think, oh no, but the base has to be on the bottom. Not necessarily. It could be any of the sides. The height, though, that you have to be careful, is the perpendicular distance from the base to the opposite side. You cannot measure this angled line, okay? Hold on, let me just draw it for you. Okay, you cannot measure this line right here, okay, that was bad, as the height, because it's on an angle. So, let me get back to this pen. This is not going to be a good height. The height would be the perpendicular line. Perpendicular is when two sides form like an L, okay? One side goes this way, one side goes this way. These two lines are perpendicular. These two lines would be parallel. So you have to remember the difference between words. Perpendicular lines, they do intersect with each other. Parallel lines do not intersect. So this would be the height. Base could either be this part or this part, top or bottom. Example number 1 says find the area of the parallelogram. Now you'll notice that this little graph paper does not give you numbers. So because it's drawn on graph paper, you need to count the number of units that is used. So if we wanted to count the height, you count each one of these boxes as height. 1, 2, 3, 4, 5, 6, 7, 8. So the height, H, is going to be 8. And area, you also have to count each one of these spots. You can kind of dash it off if you want to make it easier to see. 1, 2, 3, 4, 5, 6. So it's going to be 6. Area equals 6 times 8, which is 48. And you'll notice that this one didn't say centimeters, it didn't say inches. So instead what we write is units, squared. Because whenever we find the area, it's going to end with this squared symbol. Okay, 48 units squared, or 48 centimeters squared, or 48 inches squared. Okay, so whenever you're solving for area, make sure that you label it correctly. Look on page 539 now, example number 2. Okay, this one says to find the area of a parallelogram. Again, the formula is just base times height. You'll notice that your base is shown here on the bottom. This is 20. Your height is not 13, so be careful with that. It is not 20 times 13 because we can't say that this is the correct height if it's on an angle, okay? For example, if you're standing straight up and somebody measures you and you're 5 foot, and then if they measure you and you're kind of angled a little bit, you're going to be either shorter, probably a little bit shorter at that point. So that's why you always have to measure perpendicular from bottom to top. So they gave you that measurement here, which is 11. So you would just do 20 times 11, which is 220. And you'll notice that it was in centimeters because these were labeled centimeters. So it would be the area is 220. You can either say square centimeters or you say centimeters squared with the little squared symbol on it. Either way would mean the same thing. Okay, now let's look at letter A. Here it says got it. Again, they don't give you numbers. They don't tell you whether it's centimeters. They don't tell you whether it's inches. So we're going to be using units. You need to carefully count, okay? I'm just going to kind of put a dot so you can see. We have 1, 2, 3, 4, 5, 6. So 6 along the bottom. I know that's a little hard to see in your book. It might be a little bit easier. And then the height is going to be, I'm going to go right in the middle of this square. 1, 2, 3. 6, and then the height would be 3. 6 times 3 is 18, and you would just write units squared. 18 units squared. Letter B, first you do base times height. Base here is just a small little base. It's 4 meters, okay? 4 meters. Height, again, is not the angled one. We really don't even use this angled one when we're finding area, so you could just pretend that it's not even there. The height, though, is 16, so you would do 16 times 4, which you would end up getting 64, and then you would label it meters squared, or you could write 64 square meters. Okay? A formula is an equation that shows a relationship among certain quantities. To find missing dimensions, use the formula for the area of a parallelogram. Replace the variables with the known measurements. Then solve the equation for the remaining variables. So it's a good thing we know how to solve regular equations now, because if they only give you, for example, number 3 here, they gave you the base. Remember, the base could still be on the top. They gave you the base, which is 9, but they also gave you the complete area already, okay? So you should notice that we're missing the height. They didn't tell us what the height is. So you write out your formula. A equals B times H, okay? Then you fill in what you know already. We know 45 is the area. I'm going to put it here. We know that 9 is the base. I'm going to write 45 equals 9 times H. H is the variable that we don't know. It's called our unknown. You'll notice that this is a multiplication equation. To solve a multiplication equation, we use the inverse, which is division. I'm going to divide both sides by 9, okay? These cancel out. I have H by itself over here. We do 45 divided by 9 equals 5. So the height ends up being 5 inches. Now notice it's not 5 inches squared or 5 square inches. It's just 5 inches. You only put squared when you're solving for the area, the overall area. So if you're just finding the height, or if you're just finding the base, you're just labeling it with whatever label it already had. So this is 5 inches. Okay? I'm going to show you these. Actually, what I'm going to do right now is I'm going to do these equations on my smartboard. On my whiteboard, sorry, not my smartboard. I wish I had a smartboard. So please watch my part 2 video after you finish filling these in. Try letter C and D, and then we'll go over them on my other video.